अच्छा, और उस पे भी जाना है, मीट पे भी? मीट पे भी करना है? वो वहां से तो आप स्ट्रीम कर देंगे ना? ओके। Okay, good afternoon, everyone. Today we are starting our session on IoT middlewares, brokers, gateways, and data automation elements. Till now, what we were doing was concentrating on the things only. Till now, the data was residing on the processors connected to the sensors. It was not moving beyond that. So geographically, it was very limited. But uh, that is, but now what we are going to do is now we are going to move that data which was geographically located and was constrained to the internet. And this is the point where it actually becomes Internet of Things. So there are several blocks to it. There are several building blocks to it, and we will study about them each about each of them one by one. So since there is a plethora of tools that is available nowadays, so we will restrict our discussion to those tools which are having wide support over internet, uh, are more or less open source. So if you try to implement them, you have good amount of tutorials and support available over internet. So whatever tools, these are not the only tools that are available. There's lot many other tools. Some may be even better than these, but these are considered to be quite reputable, quite reliable, and are open source. So if you want to make some changes to them, and if you are research oriented or product design oriented, or you are having some entrepreneurial itch to you, then this is the thing that would be more beneficial to you. So out of these things, Mozilla IoT Gateway is a fully packaged product. So I'm just going to tell you what it is. We are not going to deal much with it. It's a fully packaged product, almost ready to use. You don't have to do much with it. So we are giving least time to that thing. So we will be focusing on Mosquito and Node-RED primarily. So this is the holistic view of IoT ecosystem. You can see uh, here, these are your sensors, which are sending or receive sensors and actuators, which are sending or receiving data to the processors. We have several of them, but these are geographically confined. All this data is digital in nature, is being processed by the microprocessor or the microcontroller. And this data is very very low signal strength data. It can't go far. So it can't travel on the internet. So the only communication that is possible for now is from sensor to the board, which shouldn't ideally be located more than 1-2 feet. And if you are using some wireless protocol, they may go up to some distance, but not much. So they geographically, in a sense, they are very much confined. And then you have to, when you process this data, you attach some kind of communication ability to it, either Ethernet, Wi-Fi, or long range uh, wireless transmission. So then this data, the data which has been collected from sensors and actuators, that is amplified, some error correction code and all these things are added to it, and it's now ready for transmission to long distances. And from here, it can now travel on to internet. So this data now, from this point onwards, it goes from processor to some thing which is connected to internet. So in this, uh, and then from here it can go to various layers, accessibility layer and data aggregation layers. I mean, there are a lot many things, lot many ways you want to process your data. And now next we see when several such systems are combined together, they make up this very cluttered system. Here, the sensors are talking to their microprocessors or microcontrollers. Microprocessors in turn are talking to something like a uh, request broker, message broker, sorry. And these message brokers will pass on these messages to higher up in the hierarchy on the internet, depending on how you want them to travel. So when several such systems are attached together, they make this big picture, which is uh, depending upon the situation, whether it's located more towards the user or more towards internet, it becomes fog or cloud. So that is a holistic view of this system. So till now we were restricted to this region only. All our sessions were restricted to this. And now we are moving to go to we are going to move our data to the internet now. So till yesterday we saw how we can program our ESP8266 boards using Arduino. Now today we will see how we can program ESP8266 with sorry, first of all I will outline the steps involved in making an IoT product. So steps would be organized like this. You have to prepare your sensor side processor to talk to the local network where your message broker would be situated. Uh, so this is the first step. Then the second step would be to establish a broker to listen to data from all sensors and other devices which are ready to share data. So sensor may not be the only thing in your IoT system. You may want your sensor to do something on its own. For example, passive IR sensor may detect someone on the gate and open the gate automatically if you want that to happen. Or if it senses some activity, it may turn on some other gadget in your house. So in that case, there are more than one devices which are in this ecosystem, and they should be able to share data if you want them to. So we have to establish something called as a Mosquito MQTT server. That's one of the scenarios. There are several other solutions, but here we will be demonstrating that. And what Mosquito MQTT server does is it shares data among participants in an IoT system and on a need to know basis. So a particular node may publish whatever data he is having at regular interval or whenever event occurs. So that is one of the scenario. Then there would be other devices who would be subscribing to the data whatever comes to this MQTT server or the broker. So for example, I'm a thermostat. I'm a thermal sensor. I'm continuously publishing data that temperature is 25 degrees Celsius, 26 degrees Celsius, 27 degrees Celsius. There may be other devices who are automatically listening, who are listening to this data. They have subscribed to that data. Sensor is publishing data. Temperature now is 25, temperature now is 26 degree, temperature now is 27 degree. And the AC is listening to us, it has subscribed to the data, it is listening to that data. And the moment this data reaches the value of 27, the AC gets turned on. So you can program the system like that. So, but on the other hand, you may be having a device which doesn't need to do anything for this data, even though it is subscribing to it, or it may totally ignore that data. So in an ecosystem, we have to organize this data, and for that, we use this MQTT protocol. So we will be visiting that in a moment, how to establish that. So today's exercise will be that we will be doing is to prepare your ESP8266 board to send data to an MQTT server or broker. And the MQTT broker or the server that we are going to use is the Mosquito MQTT server that is developed by Eclipse. And then from this Mosquito MQTT server, data will again be sent onto the higher hierarchy, like Node-RED, which is a data automator. It can process data on your behalf based on the predefined rules. It can store your data in databases automatically if you define it like that, or it can route your data to other parties, or it can display them on a dashboard so that end user sync could be created. So that would be the third part. And in the last part, we will be creating an UI, a user interface, where this data from the sensor would be ultimately sent to for information to the user that what actually is happening. On the other hand, despite doing all these things, you can simply use Mozilla Internet or Web of Things Gateway, IoT Gateway. It's a fairly new product. It came into limelight. I mean, it started developing in 2018 or 17, I think. It is still being developed. It's not a final product. It recently came out of its beta. So, but this is something, if you are very much concerned about your data privacy and you don't want your data to reside or travel on the internet cloud, this is the solution that you should look onto. You can extend its capabilities, and you can design your own interface. That is, for example, you can select your room plan as an interface so that you see the plan of your house, room number 1, 2, 3, and which devices are located in each room or in other places. So on that, with that kind of graphical interface, it's very easy to organize your IoT products, and you know where everything is kept and what it is doing right now. So I would just show you its installation. It's very straightforward, and there are various tutorials available over at internet. So I won't take much time because it's a packaged product for the end user. So there's not much to tell you about that, but I just wanted to share that thing with you. So the next thing that we are going to do now is to prepare an ESP8266 board to talk to the MQTT server. And we will be doing that using Python now, because yesterday we did it with Arduino IDE. You can still do that with Arduino IDE. In fact, there are various other methods of communicating with MQTT broker. But since Python is more intuitive, it's more easier to use, its code is more comprehensible, so we will be using Python. So for that, and Yes, and all this development will be done on a Raspberry Pi so that uh, it can remain on for longer period of time. It doesn't consume so much power, and you can leave it that way. It doesn't even need a screen to operate, so no keyboard screen. Once you set it up with a monitor and a keyboard, now it's ready for use with using SSH. So you don't can run on its own for a longer period of time. So let's start with that. Okay. So the first thing that we have to do is to get the Python MicroPython firmware for ESP8266 from uh, for the from this URL. So first get, I mean, this is the place from where you can see the tutorial on how to install firmware. And this is the URL from where you can get the firmware itself. So now, since I have already downloaded it, you can visit these URLs and you can learn more about them from here. Or if you want, you can download this from this URL. And now, so I have logged into my Raspberry Pi system, and the first command that you have to give is pip install ESP tools. So we will copy that command from here. So it's saying that it is already installed, but actually it would be like this. So pip is now installed. Sorry, ESP tools is now installed. The second thing is to flash your ESP8266 board, and flashing simply means that erasing the existing firmware. To erase the existing firmware, we have to give this second command. We have to, that is esp tool.py and the port number, and then the argument erase flash. So okay. So this is the second command that we have to enter. But the thing that you have to remember here is that this command string won't be same on your system, because you have to see which device you are going to flash. So to see which device you are going to flash, you again have to see the device file name the way we did yesterday. So since I have already flashed one of the devices, so I will be flashing the second one, and its ID is TTY USB 1. And let's see how it goes. USB 0 is already flashed on my system, since I told you earlier that I have attached 4 ESP boards to my Raspberry Pi. So now and actually the board that I just flashed was the one to which we install on which we programmed to flash that LED yesterday. So since the ROM is being flashed now, so it has stopped flashing now, and I have removed that camera because it was putting too much load on this streaming software, and so I couldn't show you that, but now it has stopped. And now our ESP board is not having any kind of firmware on it. And now we have to put a firmware on it. And this firmware is a Micropython firmware, so that we can program ESP8266 using Micropython. So for that, we are again copying the command from here. Let me just switch off this terminal for a while so that you can see. I'm just copying commands from here, and they are already on the slide. So I'm just copying from there. Oh, okay. So the first thing that we will be changing here is again the device file to which we have to do this. And then we have to first download the firmware from the site. We have to download the firmware from the site which was mentioned on this site. So so this is the site from where you have to download it. Okay, now you can see it. Okay. If you go on this site that is mentioned on that, here under this section, stable firmware 2 megabyte or more flash. Since yesterday, remember, our ESP board was having 4 megabytes of flash. So we will be using this one, but not necessarily every time. That depends on what is our use case scenario, because this is going to consume almost 50% of our flash. So if you are trying to develop a complex system which requires more storage, then you may want to have firmware which is less, I mean, which is a little bit more restricted in its capabilities, but is having a more smaller footprint. So that depends upon your use case scenario. However, for testing, we will use this stable firmware of 2 megabytes. Since our flash is 4 megabyte, this will consume about 50% of our, half of our flash, and get the latest one from here. So you can get the latest firmware from this site. And now, since I have downloaded that already, I don't remember where I downloaded. Just a minute. Let me see. Okay, so here it is in the downloads folder. Sorry. Uh, okay. So I am using that command, same command, ESP tools. I am specifying the port, which port will be used, and then the device file name, since the device is USB TTY USB, sorry, dev TTY USB 1. The baud rate which we are setting here is quite high. I have copied it from the resource that I shared with you. However, there were discussions on that same side that in case you are having trouble in flashing at that speed, you can try downgrading speed. You can even try 115200, and that might work. So now we have given the path of our firmware, and now we will press enter. Now you can see it's giving us information about the port number which we are connected to, the chip which is on that device. It's MAC ID. Well, one of the important things to note down here is the MAC address. This is the MAC address of your Wi-Fi adapter, which is on the ESP8266 board. After flashing this firmware, now you can start using the Wi-Fi functionality of your ESP8266, and manual that I have shared with you tells you a great deal about it. And but if you have reached up to this point, now if you will check your Wi-Fi connection manager on your regular system, you will see that there's another access point which is available now. It would name would be something like Micropython hyphen something. So that is a hexadecimal ID of your actual node, but it will start with Micropython, and you can connect to. I mean, once you flash this Python Micropython firmware on the ESP8266 board, your board starts as a access point now. So it reboots itself and starts as an access point. You won't be able to see, but here on my system, it's now being shown as MicroPython Python hyphen 96FC55. So another Wi-Fi access point is available now, and you can connect to it using password MicroPython. And remember, in this MicroPython, everything will be in a small case. However, the last N of MicroPython would be a capital letter. So if you have reached up to that stage, I have forgot to mention in the slides. So if you want, you can note down, and once you restart your, I mean, this automatically reboots once you flash the ROM. So after that, ESP8266 board starts broadcasting an SSID, which is MicroPython hyphen something in hexadecimal, which is actually its node ID. And the password for logging onto that Wi-Fi access point would be the default password. You can change it later. It's MicroPython, where the last N is capital, everything else is in smaller case. So that is how to flash your MicroPython. That is how to flash MicroPython on your ESP8266 board. The process is very straightforward and simple. However, it can be even more simplified if you are using Raspberry Pi, and I will show you how to do that now. So if you're not very much comfortable with this character or the shell window, then you can do that graphically also. And just keep in mind, till now I have already flashed the TTY USB 0 that I did yesterday as a trial. So just to check that everything goes as planned, because earlier lectures were not very much planned in advance. I wanted to have a real feel of the problems that are occurring in real time, so that we can try to mitigate them in real time also. So, but now, okay. But this time I have tried not much, but I have still tried to figure out what in what way things would go, because I have been out of touch for a long time now. So it's last 2-3 years I haven't tested. So since now ROM is flashed, now I will show you how you can do that if you want to do that, the same thing graphically. Remember, Mr. Ramanus told us, and he even demonstrated to us about using Thorny as an IDE for programming your Arduino or any other development board attached to the Python. So in that case scenario, he was also using Python, Raspberry Pi to program an other microcontroller board. So here again, we are trying to do the same thing. And since we are using through shell, the character mode, we need to forward X. And how to do that, I wanted to deal that with in our actual demonstration session, but we didn't proceed it as we wanted. So, but now you will see its capability. The software, the graphical user software is actually residing on Raspberry Pi. It's not on my system. And this, because if you want, I will show you my local shell. And if I give the command Thorny, nothing happened. It says I don't have it, or it's not installed on my system. However, when I give the same command, was it visible or not? Give the same command on Raspberry Pi, since I have already forwarded the X server. So I'm greeted with it, and now my screen is having the graphical user interface of Thorny. You won't be able to see it because I haven't shared that window on OBS. Now I am sharing it. Okay, so here is this this Thorny IDE, which is actually running on Raspberry Pi. It's not on my system. So I'm accessing it from Raspberry Pi in a graphical user interface. So this is the power of Linux that you can do. The software is residing on some other computer, but we can access it on our system. So if you want to establish a laboratory for your students, I still insist. And if someone changes his mind later on, he can still contact us. We would be more than happy to help them out. In fact, in the process, we will also learn something from you. You may be having your own unique problem sets. So let's see how to do that here. So the first thing that you will have to, okay, let me enlarge this window, because then you will be able to see that better. Okay. So the first thing that we have to do is, earlier this used to have a menu called it device, but now in the latest versions, it's not functional. When you click on it, it will show you where are all my commands. So they haven't updated the GUI, but the software is updated. So actually, we now have to go to the run, and from here select interpreter. And let me check on the OBS if it's being broadcasted or not. Okay. So once you click on that interpreter, you will be presented with this menu. And here you have to choose, sorry, ESP8266. There are tutorials on this on internet, but they are very old and they would be showing you different options in this case. So please don't go by them, see their date. They are at least 2 years old now. So please don't follow those tutorials. Follow the instruction that I am giving you right now, because this is more updated. The software has been updated and the options that are being presented are now different. Earlier there was a generic option for, but now they have a option specific for Micropython ESP8266. So here you have to use the interpreter 8 ESP8266. Okay, and then you can see all the USB devices which are attached to my Raspberry Pi. I told you that the odd man out that we discussed yesterday, the one which is having a different chip than the stated one, that is USB 0. I have already flashed that with the Python firmware, but this time we are now going to flash USB 1. Okay, so you have to select the device file, or it's being called as port here in this case. So, and then you have to uh, click on the lower option that says open the dialog for installing or upgrading MicroPython on your device. So here again, you have to choose the device. In this case, it's USB 1. And in the downloads, we are having the firmware that we downloaded earlier. So you still have to download the firmware from the site that we discussed earlier. So you have to get the firmware from that site and keep it at a place where it can be easily accessed. In this case, it's the download folders. And to see which one is the latest version, you will see that it's ESP8266 hyphen year, month, and date of releasing. So other than this version number, that is V1.13, this shows the date of the release, and that is one of the ways of identifying which file you should use. So we will be doing this. Then you have to choose, remember that before flashing the firmware, we erase the flash memory. So here you have to choose that option, or it's always advisable to erase the firmware before you write a new one, because if the remnants of the older firmware remain on your board, then they may cause some unseen problems. I mean, you will get some erratic results. System may hang frequently. So always ensure that erase the flash before installing. Then you will say, if it's that obvious, why it's not tightly integrated with this command itself? Every time we are flashing, the ESP utils should automatically flash it. It has been provided as an additional option just because some of the NANDs have this relatively limited cycles of writing, rewriting. So the developers of the software don't want to ruin your system, so they have given you an option whether you want to do that really or not. So here in this case, we are doing that and clicking on install. The same process happens here, and the same you will see output that we were getting on the command prompt, we are getting here again. So, but it's more verbose in its output than what we saw in the command prompt. However, on the command prompt, you can add the option of being more verbose. So, in the graphical user interface, you will do same thing this way. Okay, I forgot to log on to Google Meet, and in case someone is having query, let me do that. So if anyone of you want to ask something, that they can type in the chat box of the Google Meet. Now I have opened it. Earlier I was not logged into it, but now, and just a minute. Rashi ma'am?
Yes.
आपने शेयर नहीं किया हुआ है गूगल मीट पे? अरे वहाँ पे भी शेयर कर देती है ना. Okay, now we can see that the ROM has been flashed, and it's now ready for use. Once the flashing is done, the board automatically reboots, and so it's now done, and we click on OK. And so that was how we could flash our firmware on the ESP8266 board. So since now we are done with it, we will close the system. Okay. So till now we have reached up to this point. Till now we have reached up to this point of deploying or flashing the ESP8266 board. Now we will see the process of how to deploy this MQTT client library so that ESP8266 board can talk to the MQTT broker. So for that, I have given you an URL down here. So if you want, you can go to that URL and so once we open that URL, we are presented with this file, the URL that I have given you. It's a Python file. So what you have to do is you have to copy it on your Raspberry Pi and again use Thony, or you can do it this way also, I think. So I have already saved it on my Python. You simply have to copy that file from the browser. You have to paste it inside from, you can click on this new button, and in a new code window, you can paste it. And just remember that while saving it, you have to keep the name as umqtt simple.py. And then you can either run the current script. हेलो, आवाज तो जा रही है यूट्यूब पे? मैंने अपने मर्जी से मैंने कि गूगल मीट। Okay, so you have to copy that file, and then you have to save it on save as on your MicroPython device, not your computer. So you have to save it on your MicroPython device, and then you have to run this script by clicking here on this green button. So that is the way you install this library, MQTT library, on your ESP8266 board. Now your ESP8266 board is fully ready to communicate with the MQTT broker on your net. You will have to configure some parameters, but once we finish establishing this infrastructure, that means preparing ESP8266, establishing an MQTT server, and then installing Node-RED, we will come back on how to and see how we can communicate with MQTT broker. So that is all for ESP8266 now, and we now close this ESP8266 thing. Just remember that before doing anything, you have to choose your board port number here. So now you can see that this new board still don't have that file. I copied it from the earlier one. Okay, I'm leaving that for now. That may cause some problems later on. So for now, I have closed that. So with that, we are done with preparing ESP8266 for talking to the MQTT server. And I once briefly recap the steps. First, you need to install Python firmware on ESP8266. Detailed instructions for doing that are available on this website. Then download the latest MicroPython firmware for ESP8266. That is again available from this URL. Then on your computer, not the ESP board, on your computer, in this case it's a Raspberry Pi, you have to install this Python utility called as ESP tools. There are various other tools to write firmware. This one is easier. I showed you another one using Thorny. So this is the way you can go. This is much easier to type in 1 or 2 commands and things are done. And so the next thing is the first step is to erase the flash. So that is done with the help of ESP tools utilities. Erase the flash. Uh, Here you have to select the right device name. If you are doing it on Windows, it would be COM1, COM2 or something like that. But since we are doing on Raspberry Pi that runs Linux, so the device file name would be more meaningful like this one. So once you have flashed the ESP8266, you have to deploy new firmware, and for that you will use the firmware that you just downloaded, and you have to set the baud rate. All these instructions are given in this tutorial, so you please go by that, the Micropython org, which have developed this firmware. It's an open source firmware. You can make changes to it. So it's available on GitHub also, I think, but I'm not very sure. And the last thing was, once you are your ESP, till this step, your ESP8266 board is ready to run Python. Now you can program it using Python. This is the high time when you should install Minicom or PicoCom or R shell, tools like that, to start interacting with your ESP8266 board. Other than that, you can also enable the web REPL interface, through which you can now, you would be able to interact with your ESP8266 using Wi-Fi and a web browser. So you can type in the commands in a web browser that would be very user friendly. So on this tutorial, those steps are also mentioned. However, to keep it brief and don't stray away from the main focus, I haven't included all those information, but there is an option. Earlier days, what used to happen was that when you flash this firmware, that web REPL was enabled and was accessible by default. But since this has become very popular and people generally ignored setting it up with a password, so what they have done now is disabled it by default, and you can enable it only after entering a password. So that is their way of implementing security, rather enforcing security. So that is how they have done it. And uh, till you once you have done all these steps, your board, ESP8266 board, is ready to program using MicroPython. You can experiment with it. And the last portion, this last point bullet you have to follow if you want to install MQTT client library, so that your ESP8266 board can start communicating with the MQTT server. So that is all for the preparing ESP8266. Okay, so that was fairly straightforward, but there's too much of configuration, and things actually are simple, but it's just too many of them. So just follow the sequence I have mentioned here, and you will be all good to go. Now we come to the MQTT. What actually is MQTT? So it's a protocol similar to the HTTP that you have seen and other protocols. And it's not the only protocol which is used in the IoT systems for data transfer from the client devices or the end processors to internet. It's not the only option. There are several other. There's CoAP, then the even XMPP, which was the messaging protocol, and earlier Google even also used it. The days when it was known as Google Chat. Google Chat used XMPP protocol. So even XMPP can be used for transferring data from sensors and the microprocessors to internet. And when we designed this FDP, our idea was to use a protocol which is more promising and would be, and in future, it would be more predominant in the actual usage. And that protocol is Matrix. And Matrix protocol is one of the protocols which has federation at its core. So all these existing protocols, if they don't evolve in that way, very soon they won't be that much suitable for IoT work. And this Matrix protocol is what is the core of the ATAL.FDP server. That ATAL FDP chat program, that chat client, is actually working on that Matrix protocol. It's not XMPP or other chatting protocol. That's XMPP. Oh, sorry, it's that Matrix protocol. And Matrix protocol, it's not fully evolved for or fully ready to use with IoT. However, there are use case demonstrations for it. It is still evolving, but uh, the ability to federate makes it very lucrative, makes it very promising, and on top of it, it's having end-to-end encryption. Some of you might have had problem in logging to the system because not only the password, it also wanted you to create an encryption key. And the chat client was usable even without an encryption key, but is more secure if you use the encryption key. And that since if we go in that direction of having added security, that generally makes the system more complex, little. But if you want to have a secure system, you have to deal with that kind of complexity. And so, if any one of you is research oriented, or if he wants to develop a system for future needs, my suggestion is try to explore Matrix rather than MQTT. MQTT is the current standard. It's widely being used right now, but its capabilities are limited. And like all other protocols on running over the TCP IP, right? Since even in your graduate days, you might have had learned that TCP IP is a stateless protocol. Hence, everything built on top of it is also stateless. That's why we have to devise ingenious mechanisms like session management. Otherwise, there are better network protocols which have session management built into them. But since the underlying protocol is very simple, TCP IP is so simple, it doesn't have those, it doesn't have the capability to store states. That's why we call TCP IP as a stateless protocol. And everything built on top of it is naturally stateless because the underlying protocol doesn't provide any facility for storing states. So my suggestion is explore Matrix protocol. That is going to elevate most of the problems related to security, then the problems which are related to low volume payloads, their latency, and things like that. So Matrix is very promising in that respect. Explore with it. And there's a reference implementation called as Synapse, and other reference implementations are also coming up. But if you want to do something new, if you want to go in, if you are research oriented, you want to do some mature, all its features that it offers are mature for use. And so make your choice. MQTT was, as it said, that message queuing and telemetry transport. It was designed by Andy Stanford of IBM and Mr. Arlen Nipper. It was developed way back in 1999. Okay. So I never paid attention to that part. It was developed in 1999. Okay. So that's a fairly old protocol. for connecting oil pipeline telemetry systems over satellite. Good. And it's an OSIS standard since 2014, so it's dependable. And when you are using MQTT protocol, like in HTTP, when we teach HTTP to students, we say that there are this many of request methods, 11 or 7, depending upon the version. So get, put, and all those methods. Similar here, when dealing with MQTT, you have to remember some basic concepts. First concept is the publish and subscribe concept. I talked about it earlier in part of the lecture. I will again give that example. So for example, there's a temperature sensor, and its duty is to publish the temperature to a MQTT broker. It will continue doing that regardless whether someone is receiving. It will not wait for acknowledgement that a particular device has received it or not. So like in HTTP, it doesn't, it's not concerned with that. So it keeps publishing data regardless of whether the clients have received that data or not. It's very simple in that. I will keep publishing the temperature, and that's my only duty. Then, on the other hand, I may, or other devices may, keep subscribing to a particular set of data. So regardless whether the source of data is available or not, I will keep subscribing to data. If I get null value, it's perfect, no problems. I will keep subscribing to that data whether its source is available on the. This protocol doesn't check whether the source is available or not, or whether the sink is available or not. So, and on top of that, it also neither verifies whether the source and the sinks who are claiming to send the data are the same or not. So, in a way, that's a huge security hole, but that's the way it works. And so it's more like wireless networks. The inherent problem of wireless networks is that they assume all the participants to be reliable. So those are the basics of the wireless networking. So that is one of the ways, this publish subscribe. It doesn't wait for or authenticates or cares for whether what I'm trying to do has actually been done or not. I will keep doing it. Whether that happens or not is not my concern. And what they publish is called as messages. Okay, so what these clients publish or subscribe to are messages. It may be on, this bulb is on, this switch is off, or it may be some data value like 32.5, it's temperature, or the atmospheric pressure, or and it could be anything. It could be a string of it could be a string of text, and even that can happen. So that may act as command for other systems. So even a string of text can be passed, and then all these messages are organized and identified as topics. So the format for organizing and identifying these entities is like they are separated by this forward slash. So there are different levels. So for example, the university level has further room levels, and there in each room there is a fan. That fan may publish on off message. So if I am subscribing to it, I have to select that topic and its message. And then we have the broker itself, which is a central entity which receives all this published data and then distributes all this data to the clients. In case you want to have more information about MQTT protocol, general information, you can go to this mqtt.org website. And if you want to have some in-depth information about the protocol structure and the way it works, then the lower URL is for you. You can visit that URL. This has very well and in-depth explanation of how MQTT works. So these are the resources that I would suggest you should go in if you are serious about MQTT. Okay, so now we will try to install MQTT. We saw MQTT broker, and the specific broker that we are going to install is the Mosquito MQTT broker. Mosquito is a project of Eclipse, and it's an open source message broker that implements MQTT protocol version 5, 3.11 and version 3.1. So version 5 is still not very widely used, but if you are developing systems now, then you should always use version 5. It was released way some 2 years back, version 5, but somehow it's not very widely used. Probably the rate of adoption of IoT was much higher 2 years back than now. I don't know what the reason is, but still shows that download of version 3.11 is higher than 5. And this is a server like your other regular HTTP server. So it runs on a port. The standard port is 188.188.3. There is also a secure port that you can see on the, you can use TLS and SSL to secure your traffic, but that will complicate your situation on the ESP8266 board. Then you will have to enable encryption on there too. So if you're trying out, keep it simple. Don't enable SSL or TLS. So I haven't included that part because I wanted to keep it simple. So now we will see how to install Mosquito broker on Raspberry Pi. And all the steps are enumerated here. We don't have too much if you are trying to install it on Raspberry Pi, because those repositories which contain this Mosquito server are already added in the repository databases of Raspberry Pi. So you simply have to update those repository information by doing sudo apt, and after that you have to do sudo apt install Mosquito. Mosquito is the server, and Mosquito clients, so that you can check whether your server is running and do other development work. So, and once you have installed this Mosquito server and Mosquito clients, then one thing that remains to be done on the Raspberry Pi is to tell your system to automatically start this Mosquito server or the Mosquito service whenever the system restarts. So for that, we will use this command, that is sudo systemctl enable mosquito.service. So this is all about installing Raspberry Pi. Now we will try to do that on our actual machine. Okay. So I think it's now more easily visible. I have increased the font, resized the window, not increased the font size much. And since I told you that the repositories are already added for us, so we only have to do. So we have issued the command to update the repository information. So in case a newer version has arrived, so we can have that. It's showing that 77 packages can be upgraded. But right now I'm not upgrading because I've already tested this system. So in case I upgrade something and things go haywire, I don't want to risk that. So okay, one of the interesting thing about Linux is that if you don't remember or don't want to type the entire string command line, then the most plausible ones would automatically be presented to you when you press the tab key. So here, when I press tab after writing a few characters like MOS and tab, all the plausible alternatives are being shown here. So I'm typing one more character, and that's Mosquito space. So so this is the command that we have to go give sudo apt install Mosquito and Mosquito client. So we are installing, in fact, two things here, the Mosquito server and the Mosquito clients. Okay, so it tells me that this is already installed. So again, I will do the same thing. So this would be the actual thing that you would be, since I have already installed it on Raspberry Pi, so you won't get you were not able to see what actually would happen. So what actually is happening here is that it's telling us that in case you want to install Mosquito server and Mosquito client, some additional packages will be installed, which is libdlt2, libmosquito1, and libwebsockets. So these additional libraries will be installed. Do you want to proceed? And this much of additional space would be consumed on your hard disk. So I will say yes, and then it will get all the softwares for me and will automatically set up them up for use. So that was how we can install Mosquito service. And at last, we can type in this command. Okay, and this is an information thing. If you want to see the version number of the current Mosquito server that you are running, so you give Mosquito space hyphen v, and that will tell you the version number, and in the end it will show an error. You can very safely ignore this error. This actually is not an error. It's just that we still don't have any publisher or subscriber to which listen to, so it's that error. So don't worry about that. If you get this kind of thing, it's perfectly okay. Your server is running fine. Okay, now since we are done with installing Mosquito server, uh, we will now see uh, how to test whether our Mosquito server is working, or how to get the basic concept of it, how to see this publish and subscribe concept. So for that, uh, you have to do this. Uh, like I will. So for that, I will have to open few windows. Just give me some time, so and I will show you how to do that. So I'm stacking up these new windows so that you can easily see them. Okay, we are now all set. Hmm. Okay, okay. I think it's too long for. We have been doing it for so long. I will just set up the window. Meanwhile, you can go and have some refreshment. And once I have done, just give me 5 minutes. So for now, uh, we will meet after 5 minutes. So meanwhile, I will set it up so that it's presented better. Okay, welcome back. So now I have set up the screen so that you can see. You can see the 3 instances of terminal running, and each of these 3 instances is on the same Raspberry Pi. You can see that. So now you can see that we have 2 instances of Mosquito subscriptions running. Uh, in the both of them have the white background, and the terminal with the black background, we are now going to run a publisher on this. On these terminals with white background, we are having subscribers which are listening to data from MQTT server, and in the black terminal, we are using Mosquito publisher to publish some data, and data is the topic is test topic, and the message would be hello FDP. And when I press this enter here and publish this data, look, on both the receivers, the subscribers, it got updated. On subscriber, you can see that it has received this data. So this is how now so you can see subscribers keep listening to the data, whereas publisher, once publishing the data, turns itself down or shuts down or gets disconnected from the system. So this is how these publishers and subscribers behave on an MQTT broker. Publisher can disconnect after publishing data. It doesn't care whether the data has reached the intended subscriber. In fact, it doesn't have any intended subscriber. And intended subscriber never cares whether who is the source of or who's the publisher of this data. It just keeps listening to a topic, no matter who the publisher is. So that is the kind of architecture that we see in MQTT. So again, it will take some time to clear up these screens. Now, Okay, so now we come back to our presentation. So once we are done with setting up MQTT server, the next part is setting up Node-RED. It's one of the most talked about project nowadays in the IoT segment, and primary reason why it's so popular is that it does not require programming at all to programmatically send or route your data from one place to one point to another. So it's all graphical and it's all very user friendly, and it's having a very appealing user interface. So we will see it in a short moments from now, but those are the few reasons why it is so popular. Node-RED, uh, the way to go nowadays. So students would very much like this, demonstrate them to them, and it's also an open source project, and for building IoT applications. It was developed by IBM, and it uses visual programming that allows you to connect code blocks known as nodes together. They perform a task. When different nodes are, for example, a source node, an ESK to the or Arduino or anything else, and a sync node could be a smartphone, or it could be a browser or anything. So to send data from your source to sync or any other nodes or any other kind of nodes or intermediate nodes, or if you want your data from SPA206 to go into a database, thus your sync is the database, you can do all that without writing any code at all. You can all do that graphically, just drawing lines from one point to the that. It's very good, very appealing. So Node-RED also runs as a server, primarily serving out HTTP content. The actual server works like that, and the port on which the standard port, non-secure one, is 1880. And however, Node-RED is a software which can be extended as your needs bulge on. So what we are discussing here is not the complete installation of Node-RED. And if you try to install Node-RED manually, it's still a little bit more complex than MQTT or anything else we have seen so far. And that's primarily because Node-RED is not one software, but it's a collection of software. And in the background, there are a collection of things working. And to set them all the right way is little difficult. But there are people at IBM and other open sources who have figured that, who have figured out that and reduced that complexity. So one of the ways in which you can solve it very easily, that is what we are going to discuss here. So what I'm presenting here in front of you is a single command that you can copy and run on your Raspberry Pi, and this will set up the Node-RED server on your Raspberry Pi. Node-RED, please don't try to install Node-RED on Raspberry Pis older than Raspberry Pi 3 because it has some memory requirements that are higher, on the higher side. So keep that in mind when you are installing Node-RED. This is the command which I was And what we are going to do is just copy this. Copy this. Okay, so you can copy this, but beware that this is not from any authorized entity. This has been clobbered up together by some people, and not people. There are people who can add to this code, so it's fairly secure, but I mean, it's not backed by any guarantee. That's all. That's what I can. We'll again log into our, we are SSHing our, since the Raspberry Pi, our home is at this IP address. In case you want to know the IP address, you can, your Wi-Fi router, that what IP address, what IP address has been Raspberry Pi. And this -X switch is for forwarding the X server. We have already copied the command. Okay. So when you issue that command, you're on your command prompt, you will be presented with this screen. So this is giving us some instruction. You should follow that. Even if you're not following that, doesn't matter much. So what we are going to do here, that has been a, so let's do this thing. So this is giving out some instructions that please beware if you are using your machine for, if you are trying to install it on your laptop and you are using your machine for other development work which involve Node.js. So this installation may cause some problems for your other systems, especially if you are into React.js and things like that. So for Android development. So please remember that read this information carefully. And then after choosing yes for the first prompt, it is asking, do you want to install Pi-specific nodes? Pi-specific are the functionalities which are built into the Raspberry Pi. So if you are not using Raspberry Pi for actually attaching sensors or collecting data through Raspberry Pi, uh, you could disable it. You can choose no here because ultimately you are going to attach ESP8266 boards to collect data from Raspberry Pi. You are not actually using the GPIO pins of Raspberry Pi. So you can do that. Another thing is that Raspberry Pi's processor is not that much powerful as your laptop. So installation of this takes some time. As like here it is saying it can over Pi version. However, ours is relatively faster one. It's a latest Raspberry Pi 4 with 4 GB of RAM. There's also one which is 8 GB of RAM. So, but still, it does take some time. It's not as quick. No, okay, so I'm so sorry that this screen was not shared. I'm so sorry that you couldn't see. Okay, somehow my terminal window is not visible on the streaming software. So so in your case, you just have to copy this command and just it will ask you to press yes 2 times. You have to do that. It will get installed. Uh, Second thing that you will have to do is
Okay, it looks like now it's available. Okay, yes. So this is the screen that you will get when you that command. Here, it gives out some information regarding what it would replace, the version of Node.js that it will replace, since it runs primarily on Node.js. So uh, these are some of the things that you should keep in mind in case you have other development work which is dependent on Node.js. So this may cause some conflict. We will choose yes here since we are not using this Raspberry Pi for any other kind of development. Then it is asking us whether we want to install Raspberry Pi specific nodes, and Raspberry Pi specific nodes are to use functionalities which are built into Raspberry Pi itself. Since we are not going to do any of those, we can safely ignore that. However, even if you install them, there's no harm. So use whatever you want and whatever your needs are. Okay, somehow whenever this script takes over, the output is not being streamed. So rather I will use a screen capture than the windows themselves. So this is the kind of screen that you will get after. I will run it once again for you to see that I have copied. I, as I was telling you, that is giving upgradation warning for Node.js. We are typing yes, yes, and then this will start. Hopefully now you can. Yes. So it does take some time for installation, but once this Node-RED is installed, you can program your IoT environment without writing any. So that's one of the advantages. Is that it will have already done it. Didn't take much, and about to get. Meanwhile, if you have any queries regarding this so far, do post in the Google Meet. Okay, so its installation is now complete. Today we are streaming on YouTube itself, not on Google Meet. Just chip in Google Meet only if you have some queries. Okay. So now we will issue the second command, that is command to automatically run Node-RED service, and we will just copy the command from the slide, and this was pretty uneventful. And after doing all this, we have to reboot the Raspberry Pi. Remember, after the installation of we need to reboot Raspberry Pi. Let's see if Raspberry Pi has booted up again. No, not yet. Okay, so it's booted up again. And now we will see okay. So now you can see that we have I will enlarge this window so that you can see. So you can see the URL that we have provided in here, that is of so actually we just need to give the IP address colon, since it's running on port number 1880. So IP address colon 1880, enter, and you will be presented with this interface. Here on the left hand side, you will see, I will maximize this window. Okay. So now you're viewing the complete window of Node-RED. On the left hand side, you can see these are your nodes. Nodes are either, could be either sink or the sources of data. So these are categorized under various headings: commons, function, network, and output, sequence, parsers, storage. If you want, there are a few built-in nodes, and then Raspberry Pi related nodes. So if you want, you can have something in addition to it also. And you can drag and drop nodes from here to here. This is your actual flow area where you will decide the flow of data. For example, I have taken an inject node and a debug node. And if you want to make a data pipeline from this node to this node, then you only have to take your mouse over this node. You will see that there's a dot which turns into red, and just drag it over to the other node. And there you see you have very nice, now you can move it anywhere, it won't detach. So this is how to make flows from one point to another. Okay, so this is all about, so this is about the Raspberry Pi. This is not all. Now we will do an exercise where we will generate some data uh, from ESP8266, and then we will route that data. We will send that data to MQTT server that we just established. Then from here we will take that MQTT, that data from the MQTT. Look here under network, we have MQTT in and MQTT out. That means we can subscribe to data and we can publish to MQTT server. We can do both the things. We can drag MQTT in and MQTT out. Similarly, if you want, you can also have HTTP in. Then you can also have the web sockets also. So if you want asynchronous transfers, you can use web sockets also. But for now, I have shown you the capabilities. You can click on any of these and set the parameters. You can select the topic to which they would be subscribing, like test FDP that we did. Okay. And done. You can connect it to debug. And once you have decided your flows, you have to do one thing. You have to click on deploy here on top. Then only your flows are saved and they become functional. So we do deploy. Since we have not configured, so it's giving us warning. Now, this is okay. So now I have got instruction that valedictory session is about to happen in about half an hour from now. So if you people will allow, I will resume the class after that. And now I'm logging off for this valedictory session. Otherwise, even if we can't conduct class today, then what I will do, I will post up a supplementary lecture wherein I will demonstrate you how we get data from a sensor on our ESP8266 board. ESP8266 board publishes that data to the MQTT broker. We will fetch that data in Node-RED, and then we will create a user dashboard from that data where user can control another device depending upon the data received from the ESP8266 sensor. So for now, in this lecture, I have concluded three things. That is setting up ESP8266 to work with MQTT. Then we have established the MQTT server itself. And in the last part, we installed Node-RED so that we can interact with the data coming to and from the MQTT broker. So that was all from me for now. And now I'm signing off. Thank you very much for listening patiently to me. Thank you very much.